Okay, so more pieces, parts, descriptions of all of this contraption that's sitting out onto our lab counter. What is it? How do I work it? What are the pieces and parts that make it churn? How does it do what it needs to do? And we just talked about the air tanks that are required by the machine. Two tanks that are required, helium and air. And we talked about the regulator because that's what this is called, a regulator, because it regulates the air or the gas from the tanks into the actual instruments that we are using. All of our gas tanks have a regulator on the top, all right? So now we're going to move on and we're going to talk more about pieces and parts, and this is on top of the GC instrument. All right, so if I had to give you a visual of where we are talking about now, here was the overall idea of the piece of equipment that we're using today for this analysis. The gas tanks are over here to the left, and then here's the hydrogen generator that we have now talked about. In the oven of the system, that is where the column is located, and this is where separation is going to take place. And then up here at the top, and I'm just going to circle that area in red, up here at the very top, that is the area where injection begins to take place. So that is the picture that I want to focus on, and I just took a different view of it, and this is looking at it from the top now. So a couple of things here. The injector. So the injector is where sample is going to get injected, and that's going to be up toward the front of the instrument. There's a round little threaded, what looks like a screw cap that goes up there at the very top. We'll talk more about how that is made in our instrumentation courses if you take one of those, but that is an injector. So that is where our sample is going to go. And keep in mind that our sample is a gas sample, right? And that gas sample cannot leak out of the detector. So this injector, or the machine, so this injector has to be leak free. If that is not leak free, I'm going to be losing sample at the point of injection, and then the analysis is over, right? I can't really do anything else with it anymore. So there's a little bit of maintenance that can go on in the injector sites. Once more, that's for a different class at a different time, not for this one. We just want to run our blood alcohol concentration or our blood samples on the machine and get data. That's what we're after right now. So that's the injector, and in a video you're going to see the machine, how it grabs the samples, how it processes the samples, and then how it injects the samples. I've got videos of that so you can see that in action. The detector piece is also up on top, and that again is the little chimney that I like to call that right there. That is our FID detector, FID, flame ionization detector. All right, so that creates a flame because that's what the F stands for. And then that flame is going to generate heat and a little bit of vapor, some condensation if I'm not very careful. So we've got to expose that through the chimney flute. So that chimney flute stays open. That way all of that heat and stuff can escape and leave out of our machines. Up next, if I take a look at this here in the very back, I see a couple of other gauges that begin to show up back here. I'll talk about those in just a minute because gases are leaving our tanks and making themselves to the machine. And these gauges really are there just to double check everything, to make sure that that flow actually is incoming into the instrument and at the appropriate levels that they need to be. All right, so here's the injector and detector close-up pictures, I guess, of those. Sample is going to go in, of course, on this side, and it goes through the column, through the tunnel, wee, 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 and it separates, and it goes out the other end, plop, and when it goes out the other end, that's the exit. And again, that's why that has to stay open. Here's just a different view of the injector site. Once more, there is maintenance that we can do with these. We do this in-house. It's very easy to do, but that's for our instrumentation classes and not for the forensic laboratory course that we're doing now. So the injector, once more, sample is going to go there at some point in time. The gauges in the back, here's a better view of those. So once more, here is the injector, and then here is the FID detector. That's the exit point of the machine. And toward the back are 3 different gauges, and I can see those a little bit better in that particular type of view. These gases are going to be diverted and controlled in some form or fashion. There's also black markings on those as well, so that way I've got a quick reference of how fast these gases should be flowing in and out of the system. If I go a little bit closer to those gauges in the back, I'm going to see these gauges in more detail, and sure enough, I'm going to double check them before we run anything today. And when I double check them, I'm looking for that black mark, and that needle is at that black mark. That is the appropriate setting for what we call the make up gas. I'm not going to define that because, again, that's more instrumentation types of courses. But that gas is going to be used for a particular type of purpose. It is there to be used as needed, hence makeup in a way. And that is helium. That is from our helium tank. Over on the right-hand side, I'm going to see an FID piece. And the FID piece also has 2 gauges. There is one marking, and there's where that needle is at. And then here is another marking, and that's where that needle is at. Both of these are from 2 different gases. That's why there's 2 different regulators. And if you look up here at the very top, you see the end word that says hydrogen. And then down here, you see the word air. So one of these is the incoming hydrogen that's entering the machine, and the other one is the incoming air that's entering the machine. But this hydrogen and this air is specifically for the detector part of the machine. So this is the FID requirements in order to make the FID work the appropriate way. All right, so we're getting a little bit closer, not quite, but more things that we need to do and more things that we need to talk about. On top of the instrument, all right, so just for comparison here, here's my injector down here at the very bottom. Here is the detector. That's where everything begins to escape. I've got fill gauges that are somewhat hidden in the back of this particular type of area near that kind of riser on the countertop. And then above the machine, I see an auto sampler. All right. And here is our auto sampler. It's this entire contraption that I'm seeing mostly in the picture. This auto sampler is an AOC 6000 model. It is one of the newer auto samplers at this moment that Shimatsu has. And its job is to inject samples for me. So I do not need to be at the machine. I do not need to manually inject anything at all. I can just literally go over, inject my sample directly into the piece of equipment, and then, be done with it. But who wants to do that? Who wants to do that when you've got 100 samples maybe that you've got to process for that day? So the auto samplers take over and it will do that for me. The good thing with this auto sampler is that number 1, it does traditional liquid injection, and number 2, it also does the headspace injection as well. I just have to kind of modify it very, very slightly so that way it knows what to do and how to do it the proper way. But I can take normal liquids and inject liquids straight up with no headspace processing, and then I can also come in and tell it, okay, now I want to do headspace, please. And I'll make a modification on the AOC auto sampler, and then away it goes. It begins to inject headspace for me left and right, and I don't have to be there for that at all. So if I look up here at the top of the auto sampler, I see the tower. And that tower, if I zoom in, looks kind of like this. And there's not too much that goes on here. So this entire block on the AOC Shimatsu auto sampler, that block can actually get removed. And that can be switched with a liquid injector instead. So what we have on here right now is the headspace injector because we're doing headspace analysis. But if we were not doing headspace analysis, we would need to remove that piece and it just kind of snaps out, and then we would install the new piece, metal block, that is suitable for liquid injection, and then we would go into the software and make the appropriate changes. But this is the auto sampler, and this is what's going to start to move. It's going to start grabbing our samples, our vials, and everything that we need in order to process these samples with. The auto sampler is controlled externally in a way, or at least the settings are. So the settings of the auto sampler can be made here, and this is what's called the Game Boys. Because back in my day, that looked kind of like a Game Boy. In your day, it might look like an iPod or something. I don't know. But there's the Game Boy. And when I go in and make the initial settings on the auto sampler, like what trays are where are liquids going to be positioned, where are headspace vials or racks are going to be positioned, how far should it go down, where are the actual spaces so it can learn the configuration of what you've done. All of these are settings that are made upon installation, and there are very few times that we actually need the Game Boy to do anything with after that. So this is a moment because I don't get to play with the Game Boy. I don't get to feel like I'm 6 years old again. And the answer is no, not really. This is a component that's on the auto sampler. You can reset it if it gives you an error with the Game Boy. It's just an independent controller that does not need the computer and the software to do stuff. So we have to turn it on because that power supplies the auto sampler and the Game Boy, but we're never going to go to the Game Boy and actually use it at all. So when I turn the power on to the auto sampler, this is the Game Boy that now is powered on, and here is the home screen. And what you're seeing here is like HS number 1. And here is where I would go in and say, all right, these are where headspace files will be located in the auto sampler. And I save that so it remembers that kind of tray configuration, and I don't really mess with that anymore. These are not my samples. These are just where are things located. That's what this is, because I can customize it. I can make it fit what we do, and this is the way that we do that. Next up are like the agitator settings. So the agitator settings are going to be involved with the headspace, and a lot of times this is going to be, well, how long, right? How long do you want it in the headspace oven for? And then what is the temperature of the headspace oven that you want to kind of control? So that is where I would go in. It knows to do that. We can manually set it that way, and we can do that through the Game Boy. Tray holder 1, tray holder 2, again, it's wanting me to tell it where am I designating liquid samples only, and where am I designating the headspace files only. This has nothing to do with my sample names that I'm running today. It is just simply configuration. How is the configuration set up? Because I am making that decision. And once we make that decision as a lab, there's very few times that we have to go in there and change those for us, at least for us. Okay. All right. So almost finished. We'll keep talking about the headspace auto sampler here for a bit. This is one of the trays. It's just a closer up picture of the headspace containers that we are using. The headspace containers right now that you see in the picture, these are Shimatsu branded, but they don't have to be Shimatsu specific. It can be any headspace container as long as they have a magnetic top. That is what you want here. This auto sampler works by magnets, and if your cap cannot be picked up by a magnet, then these headspace files will not work. So that is something that we have to order. That's a little bit different than the Agilent systems that we have in the house. The Shimatsus are made this way for us. So this is probably some of the starter headspace files that they gave us to use in the beginning. But these are not exactly what we used in the sample prep. They did not have a Shimatsu brand on them, but they were the same size. They were made very similarly. The tops of them were still threaded, and those tops were magnet. They were just not ordered directly through Shimatsu. So those are the headspace files that you will see get loaded up in the machine. We've prepped these, we've got them ready to go, and we just need to tell the auto sampler where they're located. Our auto sampler rack that we will be using is in rack number 4. All right, so if I have the auto sampler here, and let's say that that is up on top and I'm looking at it face forward, there are 3 racks over here on the left-hand side. Rack number 1 is going to be liquids for us. Rack number 2 will also be liquids for us. And rack number 3 will be a very small rack of headspace vials that we can put in that position. So if I just want to run a few samples and that's it, I can utilize that rack number 3 and I can tell it that's what I want you to do. That's where I'm going to load them up. It's in front, it's ready to go, whatever, it's there as an option. Or if rack 4 is filled up and I need to run more samples, then rack 3 could get the overflow. So that's another reason that we've set it up this way. The liquid injections, they hold quite a few of sample vials. So I'm not probably ever going to run out with 2 racks of liquid injections. In real life, I might, but not in our lab. Okay, so rack number 4 is actually over here on the right-hand side of the auto sampler, and that is a fairly large rack, and this entire rack is dedicated to headspace containers. So that's what you're seeing in the picture. This is our largest rack that will hold headspace vials, and we're going to load these headspace vials that we have prepared in the lab procedure into rack number 4. And rack number 4, again, is over on the right-hand side of our auto sampler. All right, so that's where I'm going to stop this video. In the next one, we're going to continue to talk about the auto sampler a little bit because our auto sampler involves the heating block. So we need to talk about that next, and I'll see you then.